My name is Sofia Crespo, and this is Feileacan McCormick, also known as Dark Fractures. And we're going to share with you a bit of our artistic research. We're both visual artists, and I personally have a background in art direction, but switched to generative art, and Feileacan has a background in architecture. He's going to share more about that later. So a bit of the way I arrived to generative art and working with machine learning algorithms was actually through appreciating nature. And one of the things that fascinated me about nature was geometry, and the fact that one could find these beautiful arrangements that just visually make sense and feel so aesthetically compelling, or yeah, like a form that just visually feels pleasing, and we cannot tell why. So part of my exploration was asking myself, where's the beauty? What is it that I like? Is it the math? I mean, math as the framework we use to try to make sense of the world. Another thing that I asked while I was introduced to this practice, I had to start and learn how to create data sets for my algorithms to extract patterns from. So one of the things I really enjoy is meditating with these data sets while I'm creating them, and take my time to really visually absorb this information that to me feels so pleasing. So is beauty contained within the data set? Could that be it? Or the fact that as I began using these techniques, I had to learn so much about computer vision, things I had no idea about before. I had never learned them, and suddenly I had to learn that images are composed of 3 channels, like an RGB image, for example, or even could be more, if we look at multi-spectral imagery, for example. And as I saw these matrices of values, pixel values, I asked myself, could that be the beautiful thing in it? Because to me, it is definitely beautiful that there is an emergent thing when we look at these pixels from far away. They make sense to us, but once we zoom into these values, they are just numbers to the computer. Another part of the process is that a lot of time, while we're training an algorithm working with AI, I'm sure all of you who've done this before probably know what I'm talking about, but one has to wait for the iterations to happen. And sometimes one gets to see a tiny glimpse of what's happening while we're training. So that's something that I learned to love in a way. Maybe as an artist, I'm romanticizing this, but in a way I find it beautiful. When I share this with AI engineers, they're like, no, it's not that nice. We wish it could happen just in real time. So, okay, fair enough. Another thing that I personally find beautiful is the fact that artificial neural networks are vaguely inspired in the functioning of the brain. So researchers took something from neuroscientific research made on cats and their visual systems, the visual cortex. So actually, artificial neurons are just extracting like a basic graph from the computational neuroscience. So that could be something that to me is where the beauty lays in as well. So to show a bit of my workflow, the meditation happens from the moment I create the input, my data set, and I feed it to the neural network. I have to develop like an intuitive sense of what the parameters are for creating these works, and eventually taking a long time observing these different outputs, and also intuitively thinking which ones make sense according to what I'm trying to say. So I usually in my talks I like to share a bit of a personal story of how when I was 5 years old, my parents took me to an aquarium, and we had to watch like a 3D movie, one of the older, old school 3D movies where you use these glasses and things get close. And I saw this jellyfish swimming towards me, and I got really scared and ran out of the cinema. And eventually, as a teenager, I completely forgot about this experience. And then I was on the sea once with my family, and this jellyfish, I suddenly saw a jellyfish in the sea, and I panicked and ran out of the sea. And my mom later told me, it's interesting. You had this experience with a movie when you were younger, and now you're really afraid of jellyfish for some reason. And this phobia, at the same time, inspired me largely to create art with the textures of jellyfish. So sometimes I also wondered if all art made by humans is also a reshaping of data that we absorbed. Because no matter how hard I try, I couldn't imagine a color that I've never seen before. And I've tried. So I realized that even all the art I do is building on top of what others have created too. I couldn't imagine making art out of nothing, never have seen anything. And I'm talking about visual art, obviously, now, because that's where I specialize in, so to say. So one of the questions I ask myself is, can my brain try to understand itself using neural networks? And can we visualize natureness, just an abstract idea of nature? Can we extract something that has no direct visual meaning, like semantic meaning, but at the same time that we can recognize there's kind of a coherence in it? So I don't have any of the answers to these questions, but they are kind of what drives me to keep working and to keep trying to explore. Another one is, how can machines and living beings be related to each other? Do we need to see nature as a completely separate agent to us? Or can we see ourselves and the technologies we create as a part of the same nature and the same interconnected network? And for me, I can say I don't just enjoy seeing life in the real world. I don't think the real world and nature have to be these completely separated things. I also enjoy seeing nature emerge within a digital environment and just being on my computer and trying to make sense of the natural world that I see IRL. I also ask myself why this is. Why do I enjoy this? And could it be just my human ego that feels good? Well, with the idea of giving birth to an artificial life, I don't know. I don't know the answer to this. I can say that one of the fields that really, really has inspired me is the field of artificial life, which had a kind of a boom in the 80s and 90s, and then it kind of slowed down a little bit. And it expands through a wide array of disciplines, from wetware, hardware, software, art, and well, AI could be also seen as a part of software. And this is kind of the intersections that I'm mainly interested in exploring. Some of my very big, very big inspirations are Carl Sims. He created these evolved virtual creatures in 1994 in what back then was called a supercomputer, which for us now isn't anymore a supercomputer. It's also interesting to see how the definition of what AI and supercomputers have changed throughout time. But and basically what he did is try to teach these blocks of 3D geometry to move in a simulated physical space and to even learn to imitate real creatures. So they learn how to walk, they learn to even compete with each other towards an objective. And they're really, yeah, they're really fascinating dynamics that emerge from it. So I really highly recommend checking his work. Another really big inspiration is William Latham.
MTF.
Oh, okay, I didn't know about that. So yeah, he created this organic art in 1996. And one of the things that I really like about how he describes his work process is that he uses algorithms to evolve these creatures, and he also does like a hand curation to simultaneously while working with the algorithms. That's something that I really enjoy because it doesn't all have to be a completely detached workflow. We can, as artists, work together with the algorithm and see what we like and become more integrated in it. It doesn't need to be like a black box that's working on its own. And one of the, like going away from generative art, one of the inspirations I have is the Codex Seraphinianus, which was made in 1981 by Luigi Serafini. Originally, he was an architect, but he created this amazing book which is a collection of a bunch of different things from the real world that look like they resemble the real world, but they don't really correspond to anything that we've seen before. So it goes from, yeah, like a creature with 2 legs that has several human torsos coming out of it, or, yeah, like these flowers that just, yeah, I struggle to describe them, honestly, because they're so unique. And so this is what I wanted to create, something that makes sense in a way, but doesn't make sense in another. So if we think about artificial life as the formal definition of the study of natural life, where nature is understood to include rather than exclude human beings and their artifacts, or the way that I rather think about artificial life is just life as it could be in any kind of discipline that we want to explore it through. So rounding up more about my work, I started this project in 2018, and it's still ongoing, and it's called Neural Zoo. So one of the first things I started doing with this project was using convolutional neural networks and generating jellyfish and microscopic creatures. Those were the first 2 things that I tried to generate. So they became this collection of creatures that were emerging of data sets of nature that I just took from the internet. Back then, when I started this, I had never gone diving before. I had never had like an underwater camera to be able to capture life myself. Oh. But now I'm very fortunate to be able to do that. So hopefully, going ahead, I'll be able to create my own data sets with that. And, well, basically that. I created a wide range of natural creatures. Maybe, I don't know if I'm running out of time already. Okay, so to show some more of my explorations, a figure that largely inspired me was Anna Atkins. Maybe, I'm sure somebody here is familiar to the technique of the cyanotype, which so many artists have used over and over, and I love how it never really gets old, even though it was invented in the 19th century. And, well, she and her father were working on the very earliest photographic techniques that ever existed, and she, as a botanist, was fascinated by the cyanotype, even though the talbotype allowed you to create more photographic results. That's what people wanted to see more. But she was obsessed with this idea of obtaining impressions of plants themselves rather than trying to illustrate them, because back then all the records of nature that people had were illustrations made by humans. So she, basically what she did is placing these different plants, algae, etc., over a photosensitive, well, a paper painted with a photosensitive pigment. And basically, that's what led to this amazing results, where the parts in white are the area that wasn't exposed to the light, basically. So what I tried to do here was kind of copycat what Anna Atkins did, but my own interpretation of it using artificial nature. And so what I did is generate these creatures with my computer using a neural network, and then I printed them as folia and exposed it using basically the same technique of the cyanotype. And yeah, so that's basically it. And well, eventually I met Feileacan, so.
Yeah, hi everyone. So my background is more architectural, which I left after becoming increasingly frustrated about the lack of ecology. And as I started to sort of drift more into the arts and generative arts, I embarked upon a project to try and capture old ancient trees by using photogrammetry to 3D scan them and to create like a virtual library of ancient trees, especially since we may see less and less of them in the future due to the changes in climate. And, oh, sorry, wrong way. I was very interested in working with nature and trying to find ways of, like, I spend most of my life on computers, and how do you sort of, it gets a bit lonely there if there are only people, for me at least. I'm not so fond of people, really. I prefer nature when I can get it. So I sort of like try to spend a lot of time in game engines, like creating these like sort of fragments or these, you know, imprints of the physical natural world inside. And this led to a lot of experiments with moving around, but they were always kind of frustrating in the sense that it was, you know, very static. And after meeting Sofia, I was introduced to machine learning, something I've never really been interested in before because I never really understood the point. But then, stepping to that, I started to explore how can we use machine learning in the context of nature, because what's fascinating about machine learning isn't really the stuff it can do in a sense, but as Sofia touched upon, it's about the question of meditation. It allows you to create a data set, to curate a topic of interest on some point or another, and really allow an algorithm to work upon that and distill some kind of its own understanding or essence out of that. And for me, this gets really interesting because it allows for something to be meditated upon, just as one often does. Oh, sorry about that. In a digital space, but without us having 100% control over it. You know, you enter something in, and you wait for a while, and then you receive something back. And these sort of meditations have become really interesting in the context of artificial life, but also how can we, within the digital world, which is very much, even though we have it all on our phones and screens, the fact the power plants that generate the power are spread around the world, they digest various kinds of fuels, create electricity, and all these little devices and algorithms then, you know, use that electricity to show stuff on our screens, to process information, to turn a drawing back into a physical artifact again. So we have, in a sense, already a secondary ecosystem of digital agents. And what's interesting for me is to then sort of see how can we explore playing with artificial neural networks and these kind of things to explore how can we create presences within the digital that are, you know, exploring and meditating upon nature, but without, you know, just making a purely sort of aesthetic experience. So just as a sort of segue from that into the work that the collaborative work I've been doing with Sofia now, I started exploring more working with 3D, coming from an architectural background. 2D stuff is less interesting than 3D, of course. So I started working with like, how can we use machine learning to generate unique patternings and decorations of lamps, for example? Or in this case here, how can we have it generate whole, I'm not sure what is playing. Okay, it's not playing for some reason. Oh, not sure what that's on.
You need to click.
Okay. Oh well, it's not playing. So, here we go. Some three-dimensional flowers that were entirely generated with a neural network, and exploring how they can, have their own sort of discover their own way of blossoming and opening, closing within a digital space. Something that a process I didn't really have control over, but that developed some weird, interesting results of its own, quite different from what you'd expect to see. So, artificial remnants, which is really where sort of like the collaboration with me and Sofia began. Sofia, if you'd like to say something, maybe?
Yeah, so something I had been wanting to do for a while was take all these generated creatures onto a 3D realm, but I didn't know really how to do that. And meeting Feileacan, we both brainstormed together about ways of creating them. So basically, what we did was, sorry? Oh, we're running, oh. Okay, so this is, I'm showing here one of the first generations that we did. So we generated the geometry of these insects based on data sets of creatures that we took, like, there are these open source data sets from, that are 3D scans, maybe from some natural history museums that put them open source online. So what we did was use a GAN to generate this 3D geometry, and then use another neural network, which is a convolutional neural network that does style transfer in 3D to generate the textures. And then we also wanted to generate an anatomy for them. So we took several books of entomology that talk about insect anatomy, and we fed them to another natural language processing network. And so we generated the entire anatomy and description for each of these creatures. And this is basically the last generation that we did, which is a web experience and was part of NVIDIA GTC. So yeah, we forgot to include the link, I'm sorry about that. Okay. Yeah. Oh, this.
Yeah,
I'm sorry, why is not playing?
There we go.
Okay, yeah. So this is a bit of how we created. First, we created this data set, and then we did the step of training it and seeing like when does it start, when does the network begin to give us coherent results that actually look like bugs. And then from there, we need to manually select the ones that look most like a bug, because a lot of them just don't. And then from there, well, specimen extraction, we do some processing on them to generate this texture that's kind of like a 2D suit that's going to be projected on top of this 3D mesh. And then from there, we're generating all of these anatomies.
Yeah, I think that sums it up quite nicely. So that's sort of one of the current projects we're still sort of slowly iterating upon and getting closer and closer to artificial life. So just as sort of like a final little thing, this is just a little sneak peek of something we're working on now, which is part of residency, which is basically an entire coral reef ecosystem generated by using machine learning. So this is just like a little peek of the reef at nighttime, by way of teaser, entirely generated by training them on models of corals, undersea creatures, etc. So yeah, so thank you.